Turn to page 322 and look at number 113. One day, Leo was playing kickball. After kicking the ball, the position of the ball at time t is given by the function x of t equals t cubed minus 6t squared plus 9t minus 2. Leo decides he wants to find the total distance in feet the ball travels in 5 seconds. To help him out, Penny the penguin heard his calls. Today, Penny will show you how to find the total distance this ball traveled from 0 to 5 seconds using integrals. First things first, the position function has got to be changed into the velocity function, because finding the distance using an integral requires the area under a velocity curve. In order to do that, I've got to take the derivative using the power rule with derivatives. T cubed becomes 3t squared, 6t squared becomes 12t, 9t becomes 9, and I know the derivative of the constant 2 is 0. This is what the function should now look like. Using my calculator, I found the graph of this function. Then I shaded the areas that are bound by the x-axis, of which I am going to integrate. Now typically, you'd be able to set up the integral as such, but this would only give the average distance. This is because there are shaded regions above and below the x-axis. If you can picture this as me going in and out of water, with the x-axis being sea level, I can start at 9 feet above sea level. Then I can drop down to -3 feet. My average altitude change would be 6 feet, but the total change in my altitude would be 12 feet because I've got to add the change above and below the sea level. Therefore, we have to split the integral. In order to do this, I got to find where my function crosses the x-axis, so I set it equal to 0. Then I factor out a 3. This is quadratic, and it is factorable. I can find that the function crosses the x-axis at 3 and 1. Now I know where I've got to split up the integral. We add the integrals above the x-axis and subtract the integrals below the x-axis. From 0 to 1, it's above, and when you integrate it, you will get a positive answer, so you can add it. From 1 to 3, it's below. When you integrate this chunk, it will be negative, so I've got to subtract the negative to make it a positive. From 3 to 5, I can add the integral, since it is above the x-axis. Now it's time to evaluate. Since the integrand is the same for each integral, I will integrate it by itself, and then add in the definite bounds. The power rule of antiderivatives tells us to add 1 to the exponent and then divide by that exponent. Simplified, 3t squared will become t cubed, 12t will become 6t squared, and 9 will become 9t. This is because 9 has the invisible t to the 0 power. Now I've got the antiderivative of t cubed minus 6t squared plus 9t from 0 to 1 minus t cubed minus 6t squared plus 9 from 1 to 3 plus t cubed minus 6t squared plus 9t from 3 to 5. I've broken this down into chunks. I will first evaluate t cubed minus 6t squared plus 9t from 0 to 1. I evaluate it by doing the function of 1 minus the function of 0, the top bound minus the lower bound. 1 cubed gives us 1, 1 squared times 6 gives us 6, 9 times 1 gives us 9, minus 1 minus 6 plus 9 equals 4. When you evaluate for 0, it gives us 0. So 4 minus 0 equals 4. Next, I will evaluate negative t cubed minus 6t squared plus 9t from 1 to 3. When you evaluate function f of 3, it gives us 3 cubed gives us 27, 3 squared times 6 gives us 54, 9 times 3 gives us 27. 27 minus 54 plus 27 equals 0. We know that the function of 1 from the last chunk we integrated was 4, so we have 0 minus 4. But since there's a negative outside the bracket, the 4 becomes a positive 4. Now for the final chunk. T cubed minus 6t squared plus 9t from 3 to 5. Evaluate for the function of 5. 5 cubed equals 125. 5 squared equals 25 times 6 is 150. 9 times 5 is 45. 125 minus 150 plus 45 equals 20. We've already evaluated for f of 3, which gave us 0. So 20 minus 0 is 20. Now, all you've got to do is take the 3 answers you marked to remember for later and add them together. 4 plus 4 plus 20 equals 28. The final answer is 28 feet, since I asked you for the units in feet. In your book, it does not ask you for units.